Welcome to my YouTube channel. So in the previous lecture, I have solved one question from previous year question. So today I will discuss harmonic conjugate and solve one problem from previous year question. So harmonic conjugates. For that, we have discussed what is harmonic function. Okay. So a real value function of two variable xy, phi of xy is called harmonic function if it has partial derivatives of second order or it satisfies Laplace equation. Okay? If these two are hold, then phi is called harmonic function. Laplace equation means del 2 phi del x2 plus del 2 phi del y2 equal to 0. If this phi satisfies this Laplace equation and it has partial derivative of order 2, then this function is called harmonic function. And what is harmonic conjugate? So a function v of xy is called harmonic conjugate of u xy, of the harmonic function uxy. This is harmonic function. So harmonic function, if u is harmonic function, then there exists a conjugate of harmonic function, that is harmonic conjugate function of this harmonic function uxy if f of f equal to u plus iv is analytic. So this v will be harmonic conjugate of this harmonic function u if this function u plus iv is an analytic function in a domain like this, and also this harmonic function or conjugate harmonic all are defined in this domain. So this is the definition. So here uxy is given. So first we check is it harmonic function or not. If harmonic, then we find the harmonic conjugate function of u. So first we find ux, that is we differentiate u as with respect to x. So we get 4y minus 3x square, and from here 3y square, and uy equal to 4x, this will be 0, and from this we get 3 into 2 6 xy. Okay? And from this we get double derivative with respect to x. So again we differentiate ux with respect to x, we get this will be 0 and this will be minus 6x and this will be 0. So this will be minus 6x, and from this we find uyy, that is differentiation with respect to y, differentiation of uy. So from this we get with respect to y, this is 6x. So from this we get uxx plus uyy equal to 0. That is uxx means del 2u del x2 plus del 2u del y2 equal to 0. So this is the Laplace equation. So u satisfies Laplace equation. So from here we can conclude that uxy is a harmonic function. Okay? So if you are asking that is uxy harmonic or not, examine that uxy is harmonic. So you have to check in this way. First find ux, then uxx, uy, uyy, and let's check Laplace equation satisfied or not. If this is not equal to 0, then Laplace equation does not satisfied by this u, then we conclude that the u is not harmonic function. So in this case, for this u, so we see that this Laplace equation is satisfied. So this u is harmonic function. So first step is done. So now we find harmonic conjugate. So for that we need ux, uy. So other term I am removing. So find vxy. So we have to find vxy, which is a harmonic conjugate function. Okay, harmonic conjugate of uxy. Therefore we will get that u plus iv is analytic. So analytic means shear equation hold. So then we get ux equal to vy and uy equal to minus vx. These two are CR equations. So we use this. Simply we apply that the definition of harmonic conjugate. So V will be harmonic conjugate of U if F equal to U plus IV is analytic. So analytic F is analytic at a point means that this function is differentiable at every point of some neighborhood of that point. Okay, neighborhood means at that point also. So from this we can, if F is differentiable, then this satisfies CR equation. So from here we get this CR equation. So using this we have to find V. U is given. So first we use this equation, this first equation, that is VOY equal to UX, and UX is, we find UX. So this is UX 4y minus 3x square plus 3y square. So this is VOY, that is del V del Y. So by integrating we get V, that is as a function of xy, and from this we get 4y minus 3x square plus 3y square. This will be del y, that is dy, and as this is a function of xy and we integrating with respect to dy, so we get a constant which is a function of x. Okay, this is very important. So whenever we obtain this line from this by integrating both sides, so this will be vxy and integration of this, and as this is a function of xy and we integrating with respect to y, that is dy, so a constant term, that is function of x, will be added. So from this we get with respect to y, so this will be 4y square by 2, that is 2y square minus 3x square. So with respect to y, so x is constant, so this will be y, and plus 3y cube by 3, that is y cube, plus 5x. So we get vxy equal to this. So now we have to find phi x. Okay? This is 1. We need now we derivative this 1 with respect to x. So it will be vx and vx will be minus uy. So we need uy. Okay? We need uy. So 4x plus 6xy. We use this, and also we use this. So from this differentiating 1, differentiating both sides of 1 with respect to y, then we get vy equal to, sorry, vx with respect to x. So we have to find this phi x. So phi is the function of x, so we differentiate with that variable, that is with respect to x. Then vx will be, this will be 0, this will be minus 6xy, and this will be 0, and this will be phi dash x. Okay, this is a function of x, so we have to derivative with respect to x. So this and this, and now we use this, that is f equal to u plus iv is analytic, therefore CR equation, the second equation. So from here we get vx equal to minus uy. So you put here vx equal to minus of uy, that is uy is, so minus uy is minus 4x minus 6xy. So just compare this and this. Okay, so this is minus 6xy, this is minus 6y, cancel out. So we get phi dash x equal to minus 4x. Okay, so from this we get, so now you can remove this. So phi dash x equal to minus 4x. So now we integrating both sides, so then we get phi x equal to, whenever we integrate this, so this will be minus 4x square by 2, that is 2x square, and one constant, that is a real constant, not depending on any variable. So in this case this b was function of xy, so whenever we multiply with respect to y, we adding a constant as a function of x, and in this case this is a real constant. So now putting this phi in this equation 1, we get vxy, that is vxy will be 2y square minus 3x square y plus y cube, and now plus 5x is 2x square plus k. So this is the v. Okay, 2y square minus 3x square y plus y cube plus 2x square is. So this was given. So first we check that this is harmonic function, and therefore we find harmonic conjugate, that is v of xy, which is 2y square minus 3x square y plus y cube minus 2x square plus k. So now if you are asking that find the analytic function f, then this will be u xy plus I dxy. So just put this equation, and we get that z equal to x plus iy, then z bar equal to x minus iy. So here z bar is also conjugate, but in this case this is conjugate of a complex number, but here this vx is the conjugate of a harmonic function, but so these are two different concepts. So this is conjugate of a complex number, and this is conjugate, that is harmonic conjugate of a harmonic function. So from this we get, if we add z plus z bar, we get 2x, so divided by 2 equal to x, and from this we get z minus z bar equal to 2iy, that is y equal to 2y. So you get x equal to this in the form of z, and y equal to z minus z bar divided by 2y in the form of y. So by putting the value of xyz, you can write this in the form of z. Okay, so whenever you are asking that find f equal to u plus iv and put this in the form or as a function of z, so you have to use this, and you have to put the value of xy in terms of complex number z and the conjugate of a complex number z bar. So that's it. So in the next video, I will solve similar problem. So uxy equal to e to the power x cos y plus e to the power y cos x plus xy. So let us take uxy is a function. So first you have to check, so is uxy a harmonic function? So this is first problem, and if yes, find the harmonic conjugate of uxy. Uxy is a harmonic function, then you have to find harmonic conjugate. So I will discuss this problem in the next video. So if you're interested, you can solve this question, and you can send me in my mail ID, that is subarnomath@gmail.com. Okay, you can send if you are interested, and I'll solve this question in the next video. For today, that's it. If you like it, please subscribe the channel and like and share with your friends. So thank you very much.